So with that, I'd like to kick this off. My name is Eric Stackpole. I'm a Bristlemouth developer advocate. I am here to help all of you guys be successful with your missions. I've been really excited about this technology since a long time ago, and it's all coming together. But what I'd like to do now is really introduce you to the people who are really making this happen. And the best way to start, I'd love to introduce you to Tim Janssen. He's the CEO here at Sofar, and he'll welcome you here. So thank you, Tim.
Thanks, Eric.
Yeah.
Wow, like I don't really do much at all. Like this is Eric and his team and Evan and all the other people you're going to be hearing from today who've made this possible. But hey, this has been 7 months since we initially started talking about this in public. 7 months ago, we pitched to a crowd of very unlikely crowd, like government agencies, researchers, scientists, philanthropies, VCs. And we brought them the idea of like, can we do this together as a community? Can we take this technology that we have and bring it to everybody, make it a standard? And that was really big. And I'm going to try to get the slides up at the same time because it wasn't done before. We've created this technology, and like what Eric said, like, we've been working on it for years, but we've actually only worked on this here today for 7 months. So in 7 months, we brought together a group of partners that came in to not only support it financially, but also work with us, through networks, making it possible for us to already have shipped hardware to developers and researchers around the world, literally around the world, who are now working on it. So that timeline, to me, is pretty incredible. And I know that this will continue and will be better from here on forward. So just stepping back really quickly, like there's going to be a lot of like in-depth, presentations today. I don't have that, but here is the reason why we are doing this. And it's very simple. Like, there is a massive problem with gathering information from the ocean. It's very, very difficult to do, and it shouldn't be that difficult, right? And so really what we're trying to do is to accelerate our ability to get more information from the ocean by whatever means necessary. And one of the most important things to our mind is standardization. We're spending a lot of time and resources in doing the same thing over and over again, and it's holding us back tremendously. We don't have to do that. We can solve it. The technology is here. We just have to get behind it. So this is the problem, as you all know it. This is how we build stuff. This is how I've seen stuff being built in the ocean for as long as I've worked in the ocean environment. And it means it's going to cost a lot of money. It's not going to go particularly fast. You're going to have to bring the people that build it when you go into the field because they're the only ones that are going to fix it. And it will break. So the problem with this primarily is that it doesn't scale. I mean, all the other problems are solvable in some ways. You could throw more money and more time and more people at it. But eventually, you're going to run into a scaling issue. And I think we run into that a long time ago. And that's what we're trying to solve here. So the first question here was like, well, this isn't really what we want. We want something like this, but not quite. Because clearly you can't take USB into the ocean. It wouldn't work for many technical reasons. But we can learn from standards like it, one, to see what it did for an entire industry. And second, like, how did it do it? Like, what were the things that are needed? What are the things that are needed in a good standard to actually be successful? And that's what we've done. And so the name Bristlemouth, I'm not going to take any credits for that. Evan can do that later. But basically, it is referring to a small fish in the ocean, and is the most numerate vertebrate in the world, and nobody's ever heard of it. So there's a stealthy presence, but in incredible numbers, and that's what we'd love to see for ocean sensing. And so this is basically our aspiration and inspiration, potentially, to build something better. And so if you're thinking about scaling ocean sensing, there's many troubles, many challenges, but three in particular. There's power, communication, and integration. I think we as a community are not going to solve power. We're going to leverage other advances in other fields like solar, battery, et cetera, to integrate with, and is no longer, I think, a bottleneck for us today in most applications. Communication, still painful. Like if you're out in the middle of the ocean, iridium is probably the most common fallback, but other constellations are getting up there. And the direct result is that basically prices are coming down and options are increasing. It's great. The last one, integration. Unfortunately, we can't rely on anybody else to solve that for us. It's very specific to the maritime environment. and we're going to have to solve that ourselves. And this is what Bristlemouth is focused on. That's the thing we need to solve for. It requires a technology that we don't currently have, at least not in broad adoption across the industry. And that's what we're building here. And so Bristlemouth is basically USB for the ocean. That's how we call it oftentimes, because it's simple to call it that, and everybody sort of understands what it means. But in essence, from a technical perspective, it's the closest thing to Wi-Fi on the water. It's basically, I've heard it described as power over Ethernet as well, which is sort of like a similar, description of something like this, where we've reduced everything to the simplest possible hardware interface, connector interface, and created intelligence at each of the nodes so that we can have peer-to-peer networking. And this is very similar to other hardware standards like USB. And that opens up, an incredible, opportunity for the space. If we are able to adopt to something like this, integration should become incredibly easy, low cost, and completely scalable. And so what we've pitched 7 months ago consisted of two parts. One was, look, we can open up Bristlemouth, and we've done that. Like there's open source repositories for code, for hardware specs, everything. But really, really important is that there's access to hardware. You can actually build on it. So the Pioneer program, most of you have heard of, is basically our commitment to get hardware in the hands of developers, so you can apply and get a complete development kit for free, which basically includes a carrier board, a moat, a waterhouse, waterproof housing, and a complete smart mooring system. So you could get something in the water in days that actually becomes a real-time system, and you'd be able to monitor, get the data from it in real time as well. So everything to get you going, like an Arduino kit for, say, Arduino development, very similar. The Bristlemouth development kit is what we distribute through the Pioneer program. Accessible to anyone. Currently, we have 54 detailed applications in hand, and we expect to basically have all 120 sets shipped by Q1 of next year. So it goes really fast as well, and that's great because that is the start and the feeding ground for innovation. Here's where people can actually start working on it, create sort of like a community around it, share information, share learnings. It's really the starting point. Now, the other thing that we really want to make sure that we do is to harvest and harness and support startups. One group in this sort of like ecosystem, apart from like scientists and researchers that are using that for specific projects, are actually companies. Companies are building new technologies that's going to benefit all of us. So we as a group should and want to make sure that we support those startups as much as we can. We all know that running a startup is pretty hard. Running an ocean startup is pretty hard too. And so we got to make sure that, as much as possible, we de-risk that effort and try to have them be successful. Their success is our success. If people can build successful technologies on Bristlemouth that's going to be available to everyone, that's going to benefit the entire Bristlemouth community. So it's really, really important. This is a Bristlemouth accelerator that we're going to launch today. Similarly, as we did 7 months ago with the overall Bristlemouth open source plan. And the goal here is to have prize winners next year on BristleCon, 12 months from now, that are startups that have built amazing technology on top of Bristlemouth, and that we're all here to cheer them on. So the plan here is to have, a high-level timeline here is to final submission from startups in April, coming April, and then basically community voting in June, and then the final presentation and winner announcement next year. Now, none of this would have been possible without the partnership of Builders Vision, and we're lucky enough to have James Lindsay here to tell us a little bit more about Builders Vision perspective and vision around like what the accelerator, what Bristlemouth and the accelerator can do for the community, and where we expect to be in 12 months from now. James, please.
Thanks, Tim. So firstly, thank you to Sofar for doing everything here. You're a startup. You've got a really big job. Your team's always running around stressed and working hard. This is not to benefit your company itself. This is to benefit the entire ecosystem, which is just a phenomenal undertaking. And, we got this approved from our side to fund a couple of months ago, and it was the easiest story for us to be proud about. So a huge thanks for everything you're doing. And for full context, we are invested in Sofar. We're not a big investor. Wish we had a little bit more. And we have a lot of different tools in our office. One's very focused on supporting startups like this. I'm working with a different fund. I'm focused on stirring innovation in the blue economy. So this is precisely the kind of thing we want to see. I don't have to rattle off the importance of data, but I do want to reframe this around what data can unlock. We do a lot of work with marine protected areas. We're talking the mega projects that the United Nations is working on with USAID, with all the different DFIs. We budget 25% of the total cost of these multi-million, multi-year projects for monitoring, reporting, and verification. Some of that we can't replace because it's a marine biologist who actually has to assess what's happening. But I don't know, 80% of that actual cost is data collection. And I know this is a much broader view than just how can we think about a marine protected area, but something like that alone could significantly accelerate how we think about preserving these ecosystems. So that's just one soundbite. I mean, I believe there's still 2,000 more satellites in space than there are surface sensors in the ocean. It's just insane to think about. I mean, we're in it almost every day and we can't collect data at scale. Phenomenal, because of all the reasons Tim started this whole concept. We need to lower costs. We need to allow things to be connected and easily shared. So it's super important. Now, zoom out a little bit more on what we're doing. Builder's Vision is a family office. Our backer is purely focused on planetary health. Oceans was his first starting point. He grew up in the oceans and was just shocked at how little we cared about it as a society. And when you think about the amount of protein that comes from it, the amount of climate foundations that come from it, it's just phenomenal that we have not thought harder and harder about it. So when we're looking at the next 5 to 10 years of what we care about, and we're talking about ocean carbon dioxide removal through man-made pathways, when we're talking about climate resilience and mitigation, having this data is just going to be essential. So we're super excited to see what's going to come out of this vehicle. We're here to invest on the other side as well. That's really what my job is, to find cool, very early stage businesses that are coming out of great accelerators like this. So we're super excited to see what's going to come. So thanks everyone for being here. And yeah, is there anything else that I should cover, Tim?
That's great.
Yeah. Excellent. All right.
Cool. Thank
you. James, thank you very much. And Tim as well. Getting this started is not an easy thing. There's so much going on that needs to work together for this to be a success. Now let me see. I just need to close the shared screen here. There it is. Stop share. So this is really incredible. There's a lot of stuff coming together to make this work. You guys have really been helping to make this move forward in a business way, finding the way to connect everyone together and supporting it. Now I'd like to introduce you guys to Evan Shapiro. He's the CTO here at Sofar and is here to talk a little bit about the technology involved with Bristlemouth and where it's all going. All these parts are coming together, and I think this is a really exciting bit of where we're at right now and where we may be in the future. So please help me in welcoming Evan.
Thank you, Eric. Hello, everybody. Get this set up. Yeah, different kind of tea. Taylor, how did you do this? Oh, there it is. All right. All right. So I was waffling between two narratives for this presentation. I've got 30, 45 minutes with you all. I wanted to talk about the future when Bristlemouth exists and how exciting that's going to be and all of the sensors and applications. But I don't think I need to sell that vision to anyone. I think everyone here probably understands how direly undersampled our oceans are today. And I don't need to convince you that we should be doing more of it, and that if we do, it's going to change the world. Yeah, that's me. Our mission here is extremely aligned with that desired outcome. My personal mission here is extremely aligned with that desired outcome. That's the future I want to see. I want lots of applications to be scaled. I want everything that we need to understand about the oceans to be understood, because I think it's existential to humanity's well-being on this planet for however much longer we're going to stick around here before we all hightail it to Mars. And as Tim mentioned, and I think I also don't need to convince you, that something that will be a fundamental gate to that future is the marine technology industry adopting standards. Imagine if all of the things that we built today, you could plug them together without hardware engineering, without people like me and Eric along for the ride on the boat. Our hourly rate's pretty expensive and we don't scale very well. So this dream of having something like USB for marine tech, it's obviously going to result in these scaled applications. So that's it for the future vision. What I really want to talk to you all about is, what is the path to get here? What are the challenges that we face? Where are we today? What are the next steps? Because that's what we need your help on. Like, everyone in this room you're at the ground floor, and there's a lot of work to do. There's great progress, but I want to dive into the details of, like, what's the strategy and how are we actually going to get to this future that we all want. When I see something like this, it's an audacious goal. It's very complicated. I like working backwards. It's easier to define the milestone, the outcome that we want, and then work backwards. What are all the bits and pieces that we need to get it? So to get to this state where all marine technology manufacturers adopt Bristlemouth and we have a ecosystem of compatible things, the only thing that we actually need is for a lot of them to have already done it. There's a critical threshold of adoption where the tech no longer matters, how good it is no longer matters, how much it costs. When you build a mouse, you do not select the best interconnect technology. You use USB or Bluetooth because that's what everyone else uses. And that critical mass isn't that large. It's not 90% of the industry. It's probably less than 50% of the industry. So if we're optimizing for this future, we shouldn't be optimizing our technology development for that last 50%. That's going to happen. There's going to be a lot of hard work to do there. We're going to have to form governance and steering and standards and expand the scope of capabilities from covering 75% of applications to 99% of applications. But that's all going to be pulled. It's going to be pulled from adoption. It's not going to be driving adoption. And so to get to this state where we hit this critical threshold, that's where it gets more complicated. So if we want a critical threshold of adoption, we need to make sure that it's easy to integrate for manufacturers. If you are developing a new sensor or a new platform, you know what the path is to take this technology off the shelf, put it into your thing, and then you're in. We need some initial pioneers to use this technology. We need there to be a nascent ecosystem of compatible things that if you're a manufacturer, you can look at that and say, oh, that's a lot of people, that's a lot of users. If I build it this way, I get access to all of that. And we need people who are that organization's customer, that organization's user, to say, hey, why haven't you done Bristlemouth yet? We need some pull from the users. Even at this stage, it doesn't actually need to be the best thing. It needs to be really easy and solid, low risk, affordable to integrate. We need to have some initial adoption, and we need users to really want it. And so we shouldn't be designing the technology to optimize for these manufacturers. Where we should be designing to optimize for is step one, which is at what we're at right now. This is, how do we make this technology solve hard problems that people are going to care about today? They don't have to be academically difficult. They can be really annoying problems that take a lot of work and add a lot of risk to a project. But if we can solve those problems today, a set of those problems today, then we know we get to the point where we are driving this integration. We need at least one manufacturer to adopt the technology. And we've got that. So far is everything that we're building is going to be Bristlemouth enabled. It'll be plug and play in the ecosystem. And we are scaling SKUs of products to do that. And we'll talk about that in a little bit. And then we need people to use it. And here's the tricky thing. How do we get people to use it before anyone has adopted it? And that's where the Pioneer program comes in. That is what Tim and James shared, is like, it's not just about the technology. I still vividly remember a conversation I had like 3 years ago pitching Bristlemouth. And it was like, look at this amazing connector. It costs $1. It goes to full ocean depth. It does 100 watts in data. And it's wow, 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 wow. And the person across the table from me, a passionate ocean technologist, committed to conservation and scaling sensing applications, he's like, yeah, but it's just a connector. It's like, you're right, it's just a connector. We cannot get people who are trying to solve hard problems to care about the connector. It's the thing they don't want to care about. And so to drive these initial use cases, we're making the technology awesome. And I'm very excited that we're doing that. But we are also building direct support. It's giving people hardware and the technical support that they need. It's giving the back-end data infrastructure. It's giving accelerator programs that drive incentive for startups to build into this because they might get funding from a VC if they're successful. It's all of this surrounding support that's really going to make these initial users successful. And when they are successful, that's when we get to that next step of those people are going to say to Sofars and Seabirds and RBRs and Nortex, hey, why didn't you build this thing on Bristlemouth yet? And that's going to be one of these key pillars. So these are the blocks that we have to move. And what I'm going to focus on for the rest of this presentation is the state of the technology, the problems that it can solve today, and what the track is. So it's going to be pretty technical focused. It's going to be pretty focused on roadmap and product. So apologies to anyone who would have benefited far more from that future vision of excitement that I'm not talking about. So let's dive in. So the challenge now is, how do we solve problems for initial users? How do we make it really good for those? And we got to think about our users. And we have 3 categories of users in Bristlemouth. One are ecosystem users. So these are people who are going to get the most benefit because they are fully blocked today. I have a dream. I want to measure a conserved marine protected area. I know what sensors I need. I can plug them together. I've got the money to put them in the water. Oh no, I have to hire a hardware engineering team. They get stuck today. They stop. They don't do anything. Another category of users, which is a bit smaller, is integrators. These are people who are going to take sensors. They're going to take technology. They're going to build new capabilities. And then there's a final category, still critical. These are Bristlemouth core developers. Remember, this is, as James said, this is not Sofar Ocean. This is a separate effort. We care about it a lot. We think it's very well aligned with our mission. We think that it's well aligned with our business, but this is all open. And we are stewarding the development, but we do not hold the keys. We need more core developers to join and make it better and better for everybody. So for ecosystem users, the dream is you can take things off the shelf, you can plug them together. Maybe you're tuning configurations. Maybe you are writing some software that is for your specific data processing, which you're happy to do, but you don't have to do any work to scale hardware and get it marine ready. Today, those people don't get a whole lot. There's Spotter, and there's Bristlemouth Development Kit. These are the commercially off-the-shelf available Bristlemouth products right now. And so the people that are going to be motivated to buy these are people where these things can solve their problems. In the future, the ecosystem is going to have hundreds, thousands of modules in it. Tomorrow, not literally tomorrow, in a couple months, there is going to be a nice boost in the commercially available ecosystem. So Sofar is launching a couple new Bristlemouth modules, a single point current Doppler sensing system, which is pretty great. Our approach for now is that we're actually building these adapter. So this is Bristlemouth. This is a custom connector interface that I don't want to tell you how much it costs because I might lose my breakfast. And it's an awesome sensor. This Doppler current sensor is a really great device. You can use it to measure a lot of things. Someday, we want to see Bristlemouth ports right here instead of this expensive non-waterproof connector that you have to develop a mate to. For now, we're building interface modules. So you can get one of these and you get one of these, and you piggyback them together. and now we have a Bristlemouth enabled current meter. That's our approach with getting existing sensors into the ecosystem, because it's pretty fast, very low risk, and we don't have to convince manufacturers to adopt something and be the first one to take the plunge. So there's a current meter. We are going to have an adapter for RBR's full CODA line of sensors. So there's an adapter module that turns it into a Bristlemouth enabled device, and then you can swap in any of the CODA sensors onto that. We have our own very low cost and compact temperature sensor. In general, we think the path of least resistance is to integrate existing sensors first, and we'll find opportunities where it makes sense to actually build a new custom Bristlemouth sensor. And then there's too many to enumerate here, but there are a lot of ecosystem expansions that are going to come out of the Pioneer program itself. There are people building some very cool things, compact machine learning hydrophones, new ways of sensing chemicals in the environment, and these will all be available to anyone else who wants to build an application to take off the shelf and plug and play. Beyond that, so in the longer term future, we will have sensors that are natively Bristlemouth powered. They can be much more compact, they can be much more affordable. As things scale, that will drive incentive to reduce costs. It's not actually a big incentive to reduce the cost of those hundreds of dollars of connectors when everything else is so expensive around it. But as we start making things scale to larger numbers, as we start reducing the sizes of platforms, those really expensive bespoke connectors, they start mattering a lot more. And there will be an incentive for manufacturers to adopt Bristlemouth directly to reduce costs and make more margin. We're talking about sensors. I think that is a good thing to focus on, because most of the applications that we deploy in the ocean, there's a few exceptions, but most of them, the data is the deal. Everything else from thrusters to satellite modems to mooring systems, it doesn't matter if you can't measure the data you want. It's a sensor, it's a camera, it's audio. There are a few exceptions where you're doing real physical work in the environment, cleaning a ship hull or manipulating something underwater. But by and large, we think that the value here that is left on the table is that we are under measuring. And so the sensors are the deal. Everything else, power, batteries, processing, telemetry, those only matter if you can measure the thing you care about. And so these are all these kind of infrastructure platform level things that will come as they're needed. But the first thing to focus on is being able to measure more kinds of things more flexibly in the ocean. Next category of users, integrators. So again, these are people who are developing new Bristlemouth modules. They're the people who are putting something on the shelf for the ecosystem users to grab. This is most of the people in the Pioneer program. This is largely what Sofar is doing today and other groups. This is a smaller portion of the overall work, of the overall value that Bristlemouth will eventually deliver, but it gates the ecosystem. The ecosystem doesn't exist unless we build things that can go into that and be used by a much broader range of people that don't have to have the specialized marine and hardware engineering skills. And for these people, the biggest challenges are going to be that initial integration. It's still hard. It's still hard to get a sensor to work. It's still hard to build a brand new kind of technology. And we need to make integration as simple as possible. And so what we're doing is we're providing commercial support for integrators as well, not just the sensors you can buy off the shelf, but the transceiver module where you just plug it into your application and you're good to go. It's Bristlemouth enabled. It's all open source if people want to build their own instantiations of it. But typically, people would much rather buy a $75 board off the shelf than do it themselves so they can spend $25 on it when they're buying 10 of them, right? Do it yourself when you're going to buy 1,000. That's where you should be saving the margin. For now, we want to make sure there's robust tools that support developers. So that's electronics components, it's connectors that you can integrate into modules. It is a growing community forum and a growing wealth of documentation and examples and open source code that make it as easy as possible for you to get Bristlemouth into your new modules. We are kicking off a sprint of work next year that is focused on developer accessibility. What that means is that right now, if you really want to get under the hood and do Bristlemouth integrations, you have to have some experience with C and C++ programming languages on embedded platforms. And that's not very many people. There are a lot of people here who don't have that experience, and they're going to give it a go, and we're going to help you. You're going to post on the forums, and you're going to be annoyed that it's a one-character change that you just spent the last 3 days trying to hunt down, but you're going to get there, and we're going to help you. What we want to do is make it so that we can scale this more effectively, make it so that your motivation doesn't have to be as Herculean to actually get in there and write this code and get these applications working. And so there's a host of features that are designed to make this more accessible to a broader range of developers with different levels of experience. So things like being able to plug a Arduino or a Raspberry Pi directly into Bristlemouth, and you don't have to touch anything on the Bristlemouth side, or write Python, just simple Python scripts that you can drag and drop onto an SD drive, and all of a sudden your module is doing new behaviors, and you can build new applications that way. We're also building tools for remote access. A lot of the applications have this element of remote monitoring. You want to be able to get your data while your system is still in the field. That means you're going to be sending it over telemetry. You're going to be accessing that data from a web system. And so this is actually an example of a tool that Aqualink, who is a Bristlemouth partner and core developer, is building to make it easy for early Bristlemouth adopters to get data from their systems over a web interface. And then finally, something that the Bristlemouth team at Sofar is doing, we're building out a repository of example projects that you can do on a dev kit. This does a couple things. One is it gives you a close to plug and play usable application. You have a wiring guide, you load this code onto it, and then all of a sudden you're going. You don't have to do any of the integration engineering work yourself. You still have to kind of build the thing, do the last mile. It also shows examples of how to do different kinds of common things, use different protocols, use different power, do different types of processing. So the first couple that are coming up soon here is a Vemco receiver, which is really exciting. Like imagine if you could put a Vemco receiver, which is used for marine tracking for conservation. So they put the transmitter on animals and you deploy a receiver, and then you get data that tells you where populations are and where they're going. What if that was just a plug and play thing you could put on any Bristlemouth application? And what if a conservation group funded early pioneer developers to get a Vemco module and put it on everything they put in the water? Like imagine the scale of information you could gather on all of these migratory populations, where right now 2 researchers get in a boat and they dangle a thing over the side for 3 hours and they come back and the battery wasn't on and they do it again. Like the scalability of just that, and for one boat trip, we could distribute hundreds of these. It's really amazing. The other module that we're building a prototype of is a camera. So this is a very exciting one that's commonly requested. How do you put a camera on Bristlemouth? It's pretty hard today. So we're going to do an example that gets most of the way there, and we'll talk about all the steps that need to happen to get it over the line. In the future, the integrator support is going to transition more towards not people who are trying to do the first new thing, but now people are ready to scale. I have a module and it's great, and I want to build thousands of them, tens of thousands of them. There's more that we can do in this level of the ecosystem to provide components for OEMs. Slimmer, more compact versions of electronics interfaces, developer tools that are designed for getting integrated into existing tool chains. Like try convincing me to change our processor platform. Good luck. More compact connectors. The bulkhead connectors that you get on the development kit today, they're really easy to install. You drill a hole, you thread a thing on the back and it's good, but they're bulky and they're expensive. And that's not how we build our Bristlemouth modules. You'll see that our Bristlemouth modules don't have that big bulkhead connector. We integrate the receptacles directly. This is a manufacturing process though. This isn't a do it once in 30 minutes on your own. And we want to support other manufacturers to be able to do these things. All right, last category of users is, again, a tiny sliver of all of the people we expect to touch Bristlemouth, but just as critical. These are the core developers. So Sofar Ocean was the first core developer. This is technology that, as was mentioned, we've been building for years, lots of years, not quite a decade, but getting up there. And Bristlemouth is a culmination of that and a decision to open it up, and a decision to invest in opening it up so that we can make a bigger impact on the space as a whole. Others have joined along the way already. So Mission Robotics They focus on ROVs, and submersibles are contributing a lot to the core protocol development. Aqualink is getting started into building web interfaces and tools. And right now is the open call. If this stuff is exciting to you, not just in the sense of imagine the applications I can build and put in the ocean, but in the sense of, oh, wow, this stuff is really, really cool, and I want to get my hands in there, please reach out to us. As I said, Sofar is stewarding the development right now, but this is an open project. Everything is open source, and we welcome all contributors who are excited to do so. So let us know on the forums. When we talk about core technology, it comes down to three things. And it's really only these three things that matter in terms of, can it do its real job? Its job that, in terms of driving adoption, isn't actually the most important lever, but its job in surviving in the ocean and getting the data you want. It's power, data, and depth. And depth is a collector for all of the ways that the ocean tries to break the things that we put in it. It is barnacles and biofouling and chemical degradation and corrosion and all of that stuff, and depth, getting things to work everywhere in the ocean. Today, the Bristlemouth standard is designed to cover a very broad swath of requirements for applications in general. A subset of that is actually implemented in commercial support. So if you want to buy off-the-shelf components and put them together and have a Bristlemouth thing, today you can have modules that consume 12 watts. The standard is designed for 100 plus watts, but that's got to be implemented. There's got to be the turning that standard, that specification into, here's something an integrator can buy off the shelf, and that's where core developer comes in. For data, we have a low bitrate PHY. There are two data rates in the standard, a low data rate and a high data rate. The low data rate's much more power efficient, much longer distances. High data rate, more data, more power, more cost, lower distances. Today, you can only buy off the shelf components for the low bitrate portion, which is 10 megabits. Still pretty high, still gets you image data and hydrophones. It doesn't get you 5 raw streaming cameras on an ROV though. And then finally for the connector design, so this physical interface is designed so that we will not change the physical interface to get to full ocean depth, 12 kilometers. Today, we rate these at 300 meters. The spec calls for 150 meters. The work to go from this being rated to 300 meters and 12 kilometers is testing and validation and manufacturing process tweaks that won't actually change the mating interface. So you can have the class 2 12 kilometer rated version, and it'll still be compatible with the previous classes. For power, the next step is to get to 100 plus watts, but it's not to make everything 100 watts. More power isn't just better. More power is better when you need it, but when you don't need it, it's a waste of money and a waste of battery. And so we'll be implementing a similar approach that is done in the USB standard today, where there are different power profiles that can be negotiated. If you're a low power device, you can say, I'm a low power device, and you'll get low power joules. If you're a high power device, you can negotiate for higher power sources, assuming you've got one of those higher power sources in your application. So same type of things around what can you charge your laptop off of or power your mouse off of. USB-C today actually does all of that under the hood, and to users, it's opaque magic. For data, some of the next steps are on making it more efficient. So there are under the hood things in the protocol layer that we can do to improve the efficiency of bandwidth that's actually used, make it so that 10 megabits goes further, it's used more preciously. There are things we can do to support extremely low power devices, which is very much aligned with what we do. Is you see a lot of solar panels around here. We struggle to collect energy out in the ocean for long dwell deployments, so we're very motivated to get more and more efficiency out of this system so that it becomes a negligible part of the overall power budget. And then finally, it is the high bitrate PHY. And so the intent here is that there will be 2 data channels in Bristlemouth, one lower data channel, 10 megabits, low power, long distance, a higher data channel where you can do traditional things that you might do with gigabit Ethernet, so at least 100 megabits. And there are a few options for that core developers will be validating and testing. The intent is that they're coexistent. So you can plug and play these things, and there might be some rules around, obviously you can't get high data rate from a a camera to a temperature sensor that might only have the low bit rate in it, but we'll make it as flexible as possible, as compatible as possible. And then on the depth front, the next steps here are testing and manufacturing tweaks. We have design prototypes that have gone into pressure chambers at 12-kilometer depths, and they work. So we feel great about the design. We need people to be motivated to actually want to put some things down at the bottom of the ocean, so we can test them, and we can figure out how to test them in a higher volume manufacturing context, so that we're sure every single one of those that we put out the door is ready for that exposure. So that's it. That's the whirlwind of where we are, where we're going, and part of the why. And if any of this piqued your interest, please join the community forum. That's the best way to get started. You can also, if you're not sure where to post a message there, you can reach out to us at info@bristlemouth.org as well. All right, back to Eric.
All right. Wow. Thank you very much, Evan. And I mean, this is the first BristleCon we've ever had, the first time we've all come together. This is still early days, but already you've seen that from a technological standpoint, we are working to support the core developers, the integrators, and the people who are going to be a part of the ecosystem. You've heard Tim and James announce that we're already starting an accelerator program to help people who are building businesses around this. We are trying to get this started on the right foot, because we believe if we all work together, the rising tide will raise all ships, and this ecosystem is needed. But speaking of